Oh,
Okay, so we will continue our solving linear equations and
mhm.
we'll start with using the graphs. Did you have a chance to look at that graph exercise I sent you?
I look at it, but I can get figure out that.
I sent you the values for that equation so you wouldn't have to calculate it. You got that, right?
Which one?
The graph. You know, there was an equation that says graph y equals 3/2 x plus 2 on the grid.
Yeah.
Well, I sent you the values so you wouldn't have to calculate it. But anyway,
I had a clue.
don't worry, we'll go through it. Okay. So
Okay.
let me share my screen. And let's see which one I want to look at here. Okay. Okay, let's start with, okay, so you got this exercise, right?
Yeah.
Okay, now what I did, I sent you the values for the, well, let me bring up another screen here. Let me share. Okay. Okay, I want to do a new share. I think I have it on this one. Okay. This one, I think I have what I sent it in the email actually. Let's see. Okay. Okay. You see here, the graph of the equation y equal 4x minus 3 is given below on this grid. Now it asks you to graph y equal 3/2 x plus 2 on the grid, but I set you the values for that equation. So you could just plot them. So when you plug a 0 for x, 3/2 times 0 is 0, and 0 plus 2 is 2. So that's how we calculated y from x. Just plug in the value of x and calculate y. Okay, let me just put what I just said here. Y equal 3/2 x plus 3. Okay.
So that is for number one, right?
Yes, that's number one. Yeah, and
So I thought you had said me different numbers. I thought you said me 2 and 5, 0 and 2.
no.
So
So
Maureen,
what are we finding for y?
Yeah, see, you were given a graph, and this graph, the straight line, represents y equal 4x minus 3. Okay.
I see.
See, y equal 4x minus 3. That's what that straight line represents, right?
Yes.
Now, remember I told you when the lines intersect, that's the value of x and y for the equation. Okay, so I gave you a second equation, y equal 3/2 x plus 2, so you could graph that one on the same grid. All right, but I sent you those values so you wouldn't have to calculate. In other words, I put 0 in, like here. Okay, let's just take this one so I can just show you what I did. Okay, so let's just put this here. And so for x, the first x value was 0, so I put 0. Okay, and 3/2 times 0 is 0, right? So I have y equal, I'm sorry, this was a 2, not 3. 3/2 x plus 2. Okay. So 3, any number times 0 is 0. So that would be 0 plus 2. And what's 0 plus 2? 2. You follow it?
Yeah.
Yeah, I'm just substituting for the variable in this equation. The variable is x, because y is dependent. That's the dependent
I see.
variable on the value of X. X is the independent variable. Then I did it the same thing I did for 1. So this becomes, if I substitute 1, take the same equation, substitute the value of 1. Let's put that here. So instead of X, I now have 1, right? So this is times 1. Okay, so what's 3/2 times 1?
3/2.
It's just 3/2, right? So that's just 3/2. So Y equal 3/2. And what's 2 in halves?
2 in halves.
Yes.
2 in halves.
Yes.
Quarter.
No, not a quarter.
A whole.
How many halves does it take up to make up the number 2?
1.
2 halves. No.
2 halves is
halves.
1. 4 halves.
4
4
halves.
That's right, 4 halves. So this will be plus 4 halves. And what's 3/2 plus 4 halves equal to?
4 and it.
You can add numerators when the denominators
Because the
are the same.
numerators are the same. So you have
The denominators are the
4
same,
and
Vanessa.
the denominators. 4 and 5 is 7. 7/2.
7/2. 3 plus 4. You follow, Maureen?
Yeah.
Okay, so that's 7/2. And as a decimal, what's 7/2 equal to?
An improper fraction. So
What would it be as a mixed number?
a mixed number. It would be 2 ones 2, 2 twos 4,
3
4
over
twos.
2.
It can be 2,
No.
2 ones 2, 2 twos 4. 1 moment. Ms. Barbara, give me
Okay.
1 minute. Give me 1 minute to do it.
Okay. 2 into 7 goes how many times?
3
2 into
times.
7.
And what's left over?
1.
Yeah. So that's 1.
3 and 3.5.
That's
3
right.
and 1/2.
And what is that as a decimal?
How do you do this?
1/2 is what part? What as a decimal?
0.5.
0.5. Right.
Uh-huh.
So that's 3.5. That's how I got the Y 3.5. You follow? Substitute the X, solve for the Y. And when you get to 2, you'd have 3/2 times 2, which is 6/2, which is 3, and 3 plus 2 is 5. So you could do
Are
that.
we what are we looking for, the X or the Y?
We're looking for the Y. We are substituting a value for X and calculating the Y, because when we plot, we have a X and a Y, right? We have an X and a Y, and where they intersect would be at a X and a Y, a value of X and a value of Y. Like when you look over here, when X is, this is what, a 2, then Y is 5 right here. Okay, so you have an X value on the horizontal and a Y value on the vertical. Okay.
Isn't this the slope, Ms. Barbara?
Well, this is the slope, the coefficient of the X. So like Y equal 3/2 X plus 2, the slope is 3/2.
Where we do the
That's
yes.
right. That's like a MX plus B. Y equal MX plus B, where M, the coefficient of the X, is 3/2.
And can we do the rise over the run?
Yes, you can do rise over the run. You can take the difference in the Y value over the difference in the X value and calculate the slope.
So what if we can take, for example, I'm just throwing it out. Okay, Y2 minus Y1 over X2 minus X1
Yes, you can take,
right?
you can take 2 points on your graph. And let's just do that, what you're saying, Vanessa. We can take 2 points on our graph and calculate a slope. So suppose we say, we take this point, that's a 1 on the X and a 2 on the Y. So that would be 1
Okay, let's use, what's the
and
half?
2. That's one of the points.
Can you, beside, okay, let's say you don't have a slope. You don't have a graph.
Okay, you don't have a graph.
You don't have a graph.
Then you may have a table.
Fine. So fine, you have the table which you have there, right? You have the table.
Yeah, I can take the table right here. What
Okay.
did we put here? Okay.
Okay, and we use, okay, 2, let's use.
So what would your slope be equal to?
3.5 minus, which is
the difference in the Y values. What do you want to use?
And then you use 2,
okay,
which is the 1, and you use
3.5
0,
minus
right?
2. That's the Y values. So your X values that correspond to that would be what?
The X, it would be 1 minus 0.
That's right. So we underline, right? That's right. The Y difference over the X difference. So that would be 1 minus 0. So what's the slope equal to?
One moment. That would be minus that from that. You can get 1.5.
1.5.
1.5. And 1 from 0 can give you 1, right?
Yeah, 0 from 1 is 1, right? So that's okay.
That is
okay. So this will be 1. So what's the slope?
So the slope is 1.
What is the slope? 1.5 over 1 equal what?
Equal. You have to.
Any number over 1 is just equal to that number in the numerator, right?
Yeah.
So it's 1.5.
Right. It can be 1.5.
Yeah, like 4 over 1 is 4, 5 over 1 is 5, 1.5 over 1 is 1.5. But isn't that what our slope is? Right here, 3/2 X. There's our.
You have the answer at number 1 where we have to solve it.
Yeah, see, I'm using these numbers that came from substituting in this equation. So whatever I get for the slope must be 3/2, and 1.5 is 3/2, right?
3/2.
1.5.
But what is the solution to this system of equation? I cannot see D. What is D?
Oh, all right. Let's.
Can you scroll up?
There's D.
D is
3.9.
3.9. Yeah, but if the slope, so therefore the slope is.
No, you're not looking for the slope when you say the solution. You're looking for, when you plot that second line, where does it intersect with that first line? That would be your answer.
Yeah. So why is the answer key there?
Well, because to get the answer, it says the graph is Y is equal 4x minus 3. And that's this grid. Graph this equation on the grid. Now, that's what I did in, let me bring up this one. Let me do a new share and bring up this one. Okay, now what I did, I took those values that I gave you and plotted them on this graph. And where do they intersect? Right here. What are the X and Y values when the lines intersect, Vanessa?
I can't see it. It's pretty small. Can you make it larger, please?
Let's see if we can. Actually, I can't make it larger. Let's see if I can zoom in. Is that better?
No, it's very, very fine.
Yeah, I
And
know.
I wear
But
glasses.
anyway, it's 1, 2, 3, 4, 5. And this
Yep.
is 1, 2, 3, 4, 5. Well,
Yeah, but I was asked if you can just open it some full screen.
okay, here we go. I did the zoom in. Is that better? That better?
Yes, this is better.
Right. Yeah, I did this.
Because we have the table.
Okay, here we go. That's even better.
Yeah, because we have, you have an answer key to the bottom of the graph. Right?
Yes, yes.
And we have a table, you call it table of value, right?
Yeah. Well, this one you had to set up your table by substituting in the X and solve for the Y. That's what I gave you on the other screen. And once you get the Y values, then you can plot them.
Oh, so you did not give us the table. We had to set the table up
Well,
ourselves.
I gave you the value so you wouldn't have to set it up. That's what I showed you on the other screen. See, I took this equation and I plugged in values of X of 0, 1, 2, 3 and solve for Y. So that was your table. And then you could go to this graph and plot on the graph those values. Like when X is 0, Y was 2. That's why we have it right here, the dot. If you follow what I'm saying?
I am kind of lost.
Okay, let's go back.
Because that's why I was asking you, putting in the y2 minus y1 over x2 over.
Yeah, so you're not calculating the slope here. You're trying to find where the two lines will intersect. The line that comes from y equal 4x minus 3, which is already drawn for you, and the new line y equal 3/2 x plus 2. That's the line you need to graph. That's why I did the table. So then you have an x value and you have a y value of x.
Yeah, but we still have, because we have the answer key, that is what is going to throw, for me, it will throw me off, because where the slope is, or the y is, I'll put in, okay, I go and look at the answer key.
Say, what is the solution? In other words, these are what x and y value shows you where these lines intersect. That's what you're asking. What x and y values show you where these lines intersect?
So you do each one of them individually.
When you say each
this
one,
is not the answer key.
This is the answer you put for the intersection, the intersecting. Now, what is the value of x and y at this point? This is where they intersect. What is x, Vanessa, and what is y?
For which one?
This is where the lines intersect, right here. See where I'm going right here, that dot right there. What's the value of x and y at this point of intersection?
It intersects at 2.
2, very good. That's
5.
x, and that's it, 2 and 5. So that would be your answer.
Or you wanted where it was intersect.
That's right. The solution of the equations are where the lines intersect when you're doing it graphically.
Yes.
Okay. Where these.
So therefore, the others, even though the other numbers are there, A, B, C, and D, that's why I was asking you if they're the answer key for the graph.
They are points on the graph, but they're not where they intersect. Now, like 0 and 2, you have 0 on the x, 2 on the y, but they don't intersect here.
Yeah, I know they don't intersect.
Right.
So that's why I was asking if they're part of the what should I say, the sum, the equation.
Yeah,
But because they're not intersect, so I have to choose the correct answer from the answer key to say if they intersect.
yes, the answer to number 1 is where the two lines intersect, the X and the Y values. But
Yes.
you have to plot that second equation in order to know that. See, they only gave you the one line. And what I did, I set up a table of X and Y values for this equation. And these are the points I got. So I plotted them all here. And then I drew my line and I said, okay, they intersect here. What is my X and Y value at the point of intersection? 2 on the X and 5 on the Y. So that's the solution of my two simultaneous equations.
So if we had a table of value, which you had on the other page.
Right.
And we do the YX, Y minus, Y2 minus Y1, X2 minus X1. And we take it from the table of value. Was it possible for us to get the answer from that?
Yes, because all you need to do is look at your two tables, and wherever you see the X and Y values that are the same, that's the solution. And it's only one place where that they have in common the same X and Y value. And what is that, Vanessa? What is that one place?
I know the X2 and the Y is 5.
No, and number 2, where you're doing it by the table.
Where?
Okay. For number two, that's where you're doing it by the tables.
I would do the Y. I would do the rise over the run, where I take 2Y and 2X and.
No. When you have a graph, the point where the two lines intersect is the solution of the simultaneous equations. If you have two tables, the X and Y that are the same in both tables, that's the solution. So you look at your two tables and you find where are my X and Y values the same, exactly the same. And there's only one place. What is it, Vanessa? When you look at these two tables, which place do you see the X and the Y value is the same?
The X and the Y value is the same.
Yeah, the X and the Y value in this table is the same as the XY pair in this table. There's only one place that's true. And what is it?
Oh, C.
That's it. That's it. Because right there, they're the same. That's your answer. So for a table, it's where the XY pairs match. For a graph, it's where the two lines intersect.
Well, Miss Barber.
Yes.
I do the graph, right? But the one that you do at first.
Yeah.
I didn't even think about that. You see, one that you got here, like Y equals to 4X minus 3 is given.
Yeah.
I didn't do that.
Well, that one is already drawn.
I know.
That's the straight line. That's this line. That's done. What you had to do was find the value of Y for selected values of X and then plot them. That's what I did. I gave you the value so you wouldn't have to calculate it. So then you just put when it's 0.
That's the one that you do at first, and the one that I never looked at because that was by itself, right? So I didn't think about that. Because I see that was only that one. So I went to the others. I went to this one and number 2 and number 3. Because I didn't figure that, but the first one you give me that you do first.
Yeah.
I didn't even figure nothing about that. So
I
was lost track there.
Oh, you didn't look at what I gave you for the values in the table for this equation?
No, because I didn't know it was for that.
Oh, but that's why I said number 1.
Oh.
Didn't I say number 1?
Yeah.
So,
But then when you give me different numbers, I get confused.
okay. All right.
Yeah.
I
But
thought I thought
I
I was
already done it. Yeah.
okay. So what value did you get, Maureen?
I get 2 and 5, I get -1 and 3, and the last one, I don't know if the next one I get,
So how did you do number one?
I just figure out on my phone, right? I
No.
said 2, because you said 3 over 2 and 2, right? So I went from in between them, went up, I went as far. And then this other one, I can't remember how to do that, but I done them. You know what I mean? And number 3, I don't know if I do 3, but I get like B for number 3.
How did you do number one?
I just figured out on my phone because it was very confusing because it was very confusing to me. So I was doing it all the time, like trying to trace it from my phone, but not to scratch my phone. Yeah.
Well, you don't have your computer anymore?
Yeah. But I didn't pick it up on my computer. Because if I know if I got it on my phone, it would come up on my laptop. I would do it from my laptop. Yeah.
But I still
Well,
don't
I get
understand how you got the answer. You still haven't told me how you got the answer.
I don't know. I tell you, I figure it out. Cause I know it can be 0 and 2. I know it can be 3 and 9. No, I know it could be 5 and 2. Cause if it's 5 and 2, it'd be the other way. It was going the other direction or something like that.
Well,
That's how I figure it out.
there's a way you can figure it out without plotting. Just like we've been doing with our other, finding the solutions to our simultaneous equations. You could use the methods we use, elimination or substitution. I mean, okay, but I gave you the value so you could plot it on your graph and then see at the point of intersection. That's where you get the solution to see. These are both simultaneous equations. One is y is 4x minus 3. The other one is y equal 3/2 x plus 2. And we could solve it using our elimination or substitution. But I just wanted to show you another method of solving it. You follow? Yes, Vanessa.
So when you use, the first one, I'm still trying to fathom it because you give graph of equation y equal 4x minus 3 is given below.
That's the straight line.
Okay, fine.
Okay.
You said below graph y equal 3 over 2 x plus 2 on the graph, right?
Yes.
If where there is, and we have to find where it crosses or where it intersects.
Right.
Right?
Yes.
If where x is, let's say, you know me, I like the elimination. Substitution, please. I'm not it.
Okay.
I would always tell you that.
Okay.
So if, for example, I take A, which is the first one, right? The first answer. And I plugged in 2.
Right.
I plug in 2 where x is.
Right.
You move x and you plug it in, you put it in parentheses.
Okay.
Plus 2. I would get 5 for the y. So I would get parenthesis 2, parenthesis 5.
Right.
And when I let's say I don't have a graph.
Okay.
But they have these answers and I have to
plug
it in.
Right.
Right?
Yes.
But you're telling us where it intersects. But sometimes you go to the exam and you don't have the graph to do it.
Okay. So you do exactly what you said, Vanessa. Plug in the 2 for the x. 4 times 2 is 8 minus 3 is 5. Plug in the 2 right here. 3/2 times 2 is 6 over 2 is 3. And 3 plus 2 is 5. You say, okay, that works. That's my answer. And that's perfectly fine.
Fine.
Unless, that's perfectly fine. Now,
Uh-huh.
unless you had to actually show a graph. If you just had to pick a solution and you didn't have to graph it, that would be the way to go.
Okay.
Plug
So
in the Maureen, did you do that?
Yeah, I do it, but I was doing it on my phone.
Yeah, but did you plug in what Vanessa say, like 2 and 5 mean X is 2 and Y is 5. So if you put a 2 in this first equation and you get 5 for Y, and you put a 2 in this equation and get a 5 for Y, then that's the answer.
Okay.
Okay. Because if you put a 0 here, you get 0 minus 3 is minus 3, and you put a 0 here, you get a plus 2. They're not equal. And that would be the same for the other choices. They won't be equal. Okay. All right, Vanessa, that answers your question?
yes, Miss Barbara, thank
Okay,
you.
okay. And then, and as I said with the table, number 2, wherever your X and Y pairs match, that's your answer. And there's only one place that happens. That's when X is a -1 and Y is a 3. So your choice would be C.
Okay.
All right.
Okay.
All right. Now let's look at the next one. Okay. Now, what answer did you get for number 3? Anybody?
Let me see number 3.
I get B.
You get what?
B as in boy.
What did you get, Vanessa?
I didn't do it, Miss Barbara.
Okay.
And I don't know
Well,
how you get
I was so tired. I worked for the election. I was so doggone tired.
oh yeah, that's right. That was a long
Yes,
night,
I worked
right?
for the election.
Oh yeah, they needed people. I saw that. They wanted people to apply.
Yes.
Okay, these are the 2 equations. All right, let's go to my next screen. Share. Okay.
So you had to get 2 answers, right?
You had to get, no, that was one answer.
One answer.
Okay. Number 3, let's go to number, okay. Here, number 3. Okay. Now, Maureen, you said you didn't solve this one. You said you got C, a B?
Yeah. D.
Okay. You got D.
Yeah.
Okay. Now, Vanessa, how would you solve this?
I know
Elimination
probably-
or substitution?
I love elimination.
So how would you solve this using elimination? Let's copy the equations. Okay, so how would you solve this using elimination?
This.
Yes.
And what is the value of X?
What is the value of X?
What is the value of X?
Yes.
So you have to do both of them.
So how would you eliminate, and what would you eliminate? X or Y?
I eliminate one.
You have to eliminate X.
Or Y. So what would you do to eliminate one of them?
Eliminate X.
So 3x ax y equals to ax minus
I equals minus 8. Not that. Oh.
What would you do first, Vanessa?
Not going there. Can't remember, Miss Barbara.
Actually, this one is easier to do with substitution. Why? Because you give them what y is equal. So let's just call this equation 1. See, you have to pick the one that's best for the situation that you have, all right? So this one, okay, that's okay. You put it over here. This is number 1. Okay, and this next one is number 2. Now in number 1, you're given what y is equal to.
Mhm.
So you could really substitute that y value into the second equation, right? Because you said y is 8x minus 8. So you can substitute number 1 in number 2 for y. All right, now what would that give you? Now let me just put that over all together so we can stay on one screen to do it. All right. Now, if we substitute, what do we get, Vanessa? If I substitute for y in this equation,
If you substitute,
I want to take this equation and I'm going to substitute what y is, which is what the first equation says, what y is equal to, right? So let me just take this. And for y, we want to put what y is. Y is what we have for number 1, right? So that would be 2. This would be 2 times what y is, 8x minus 8. Okay, so we just took y equal 8x minus 8 and substituted it here for y, where we have 2 times y. So that becomes 2 times 8x minus 8. Now, next thing we do is multiply, right? What's in parentheses? So this becomes 3x.
where did you get 2 from, Miss Barbara? Oh, you substitute.
Yeah, I substituted number 1 equation, y equal 8x minus 8. So instead of 2y, this becomes 2 times what y is equal to, 8x minus 8. Follow?
Yes.
So the 2y becomes 2 times what y is equivalent to in the first equation, 8x minus 8. So 2y becomes 2 times 8x minus 8, because that's what equation 1 says, y equal 8x minus 8. All right. So what do I get, Vanessa? 3x. What would I write next?
16x.
Okay, so that's plus 16x. What else?
Minus 16x.
Minus 16. Because that's
16.
constant time a constant, right? 16. And that's equal to minus.
Equal to minus 16.
Right. And what do I do next? Combine likes. 3x plus 16x is what?
19x.
19x. So I have 19x minus 16 equal minus 16. Then what do I do next?
You You add, right?
Right, I add because I'm subtracting the constant, so I have to add it, right? Add 16 to both sides, right?
Mhm.
Add 16 to both sides. And let's just do that. Let's just put the 16, take this equation, add our 16 to both sides. Okay, so add 16 on the left. Add 16 on the right. What do I get on the left, Vanessa?
On the left again, 19x.
That's right, because minus 16 plus 16 is 0. So 19x. And what's a minus 16 and the plus 16?
Minus.
No, minus plus, same value, always 0.
My,
Right?
oh,
Right?
yeah, 0.
That's 0. Okay, then what do I do next?
Divide 19.
That's right, divide both sides by 19. By 19. And what's my answer?
That's a great one.
What's the answer? On the left, 19x divided by 19 is just x, and 0 divided by 19 is just 0. Any number 0 divided by gives you 0. Did you get it, Maureen? No, you didn't tell me that. What did you tell me?
No, this is the problem, right?
Huh?
No,
So
I didn't
answer
listen.
is A.
Um,
Yes, Maureen. You told me B, right?
yeah, but how I do it at first, when I do it at first, you see the 3x plus 2y equals a minus 16.
Yes.
I didn't even figure nothing about that. All I do was y equals the ax minus 8. That's the only one I did. And I get 0. And then I said, but the other, I can't figure out the other one because it was 2 answers. So I had 2 answers. I had A and I had B because I had 2 answers because I think it was 2 different answers.
No, it's only
I
one
got one.
answer. It's only one answer. No, because I just asked
I
you what
realized
was
that now.
x equal
Yeah.
to. Now, when we were solving simultaneous equations, you giving me a x and a y value. But this one very clearly asks you what's the value of x, right? Isn't that what it says?
Okay.
Okay, I think it just said, what is the value of x? Let's see. What is the value of x in the solution to the systems of linear equations below? So you have simultaneous equations, but it asks you what is the value of the x. So that's what we saw for, and you should have gotten 0. Any questions on that one? Number 3. Now you could solve for y. I mean, you could plug 0 into here and that would be 0. So y would be a minus 8.
Where would you plug the 0 into?
Oh, okay. You could put it in equation 1 or equation 2. I would put it in the easiest one, which is 1. Put the 0 here. 8 times 0 is 0. 0 minus 8 is minus 8. So y would be equal to a minus 8. And you can see that's true because if y is a minus 8, that means x has to be a 0 to get a minus 8 over on the right side. Any questions on number 3? Okay, let's do some word problems. Now, before I forget it, next week, the 11th is a holiday. So 1199 is closed. We don't have classes. So I'll be sending you algebra review worksheet of 5 problems for you to do, and you can text me the answers. They're all multiple choice.
Ms. Barbara, could we do some more some functions, please? I have exams on Monday.
Okay, you want to do some functions.
I don't need a word problem because for real word problems do come, but they don't come much.
Okay, all right. So let's see. Let me, okay, I have some, wait just a minute. Okay, let me, let's see. Okay, I have to go out and come back in because I do have some function problem. Okay, let me minimize. Okay.
Yeah, but or if we can do the same linear, but not in word problem.
Now you mean
If you have-
functions like substituting in for functions? Let's see. New
Okay, you have
here.
function notation there. Okay.
Yeah, okay. All right. All right. Okay. Now, one thing about functions, if you given XY pairs, remember you only have one Y for every X. So if you given pairs, if you have X value appearing twice, then those set of pairs do not represent a function. That's one way you ask about functions, because an X can only pair with one Y. Okay.
So X, wait, you said repeat, please.
Yeah.
So
if you have
function, what is a function?
A function is a relationship where there's only one dependent value for the independent value. In other words, if you have XY pairs, you cannot have your X repeating. Once you see your X repeating in a set of XY pairs, then you know it's not a function. Let me go out and give you.
Give me an example.
Yeah, let me give you another
visually.
example. Okay. Let's see. Let me give you, I want to give you an example. Let's see. Now, you know, okay, so you should know the domain of a function represents the X values and the range represents the Y value.
Y value, yes.
Okay, let me just see if I have. Okay, well, let's just look at a table. We can do it from a table. Can you see this?
No, you haven't changed it.
Okay. Let's see. Let's see, new share. Okay. Trying to bring in some functions here that have those examples.
Hey, Miss Barb, I'm sorry, I've been here, right?
Okay.
Good afternoon. I'm sorry, I
Good
had to step
afternoon,
out, do
Chastity.
something, but I had to step out, do something with my husband, but I'm on it and I have everything ready, okay?
Okay. All right. Let's see. I want to find something for Vanessa here. Well, actually, I could just give you some pairs. Okay, let's see. Okay. Okay. Okay, I don't want to give you that one. Okay, can you see this one, function explanation and examples?
Functions.
Let's see.
This it has a B date mark. Find the value of X makes. Okay, yes.
That's
Yes.
not the one I want. Okay. Oh, can you see function notation, explanation,
Yes.
examples? Okay. Now, indicate if the following relations of functions. All right. Now, these are X, Y pairs. Now, X is 2, X is 3, X is 6, all different. So that's a function. If I had a duplicate X value, then it would not be a function, as in number 2, because number 2 has a -1 and a -1, not a function.
Where?
You see number 2, not a function?
I don't see that.
No, I don't see that.
Oh, you
You
don't
got
see.
something that's different.
Okay,
You
new
got
share,
functions, you got application,
new
expression, and
share. Let me
examples.
see. Function. No, that's not the one I want. New share. Okay, can you see it now? Function and function notation?
Yes.
Okay, you see, indicate if the following relations of functions. You see that?
Yes.
Okay,
Yes.
now, when your pairs have X values that are different, all different, then those relations represent functions. Now, these are XY pairs, X2, Y4, X3, Y -7, X6, Y10. These pairs represent a function because all of your X values are different. If I have duplicate X values, then they do not represent a function. Like in number 2, notice X -1 appears here and X -1 appears here. So it can't be a function if the X values are paired with more than one Y value.
Okay.
Okay, so it has to be different X, Y pairs. You follow?
Yes.
Okay, so for XY pairs, they are relations now, because relations is an input with an output. But with your input and output, they have to be a one-to-one different pair. Don't worry about the Y's. The Y's can be all the same, but your X values have to be different. So once you see you have the same, you have different X values. If you're looking at pairs, then you know that's a function. Once you see duplicate X values, then not a function. Like
Okay.
number 3, you have 2, 9, -4, -8. All different.
That's a function.
That's a function. Now, let me ask you, Vanessa, what are the ranges in number 2? What numbers represent the range in number 2?
The range,
Yes.
8, -7, 6, and 0.
That's right, because range is the Y values and domain is the X values. All right. Another thing you need to be able to do is substitute, and this is just like we've been doing with our linear equations, except we call it a function. If f of x, and we say f of x,
X, yes.
3x plus 9, then f of 2 means wherever you see a variable, you want to put a 2.
Yes.
That's why we say f, and this right here, just to make it really simple, we say f of 2. F of 2 means for the x, we put a 2. So 3 times 2 is 6 plus 9. So f of 2 is equal to 15.
Yes.
Okay. And you can do this with operations. In other words, you could say, what would be, let me ask you this, Vanessa, what would be f of 3 minus f of 2? What's that equal to? What's that equal to, Vanessa?
F of 3. So with the same sums they have there?
Yeah, with the same f of x. What's the difference between f of 3 and f of 2?
Difference.
Well, we know what f of 2 is. What's f of 3? That's a mental math.
Oh, f of 3?
Yes.
Okay, okay, 3 is 9. 9 plus 9 is 18.
So that's 18. And f of 2 we've already found, right? 15. And that's 15 from 18 would be 3.
3.
Okay.
Okay.
So you can do calculations on the functions. Once you find the functions, you can add the values, you can subtract, and they don't always have to be numbers. They could be variables, right? For instance, let's take the same f of x. Okay, copy it on the other side. Okay. And I put this here, and I want you to find f of a plus 2. Find f of a plus 2.
Okay. F of a
plus 2. That means wherever you see the variable x, you want to put a plus 2.
Okay. So this is 3x. So you put a is like 1.
Okay, so I put f of a plus 2. What's that's going to be equal to, Vanessa?
So therefore you add this. Yeah, this is 3 here, you add this. Yeah, this is 1.
Wherever you see an x, you want to put a plus 2.
Yes.
Right? And that's plus 9. And what is that equal to?
Oh, you do distributive. So you do 3a.
Right, okay. So that would
So
be
you do
3a.
3a plus 2 plus 9. So you bring down the 3a and you add so you get 3a plus 11.
That's it. That's your answer. 3a plus 11. So you can substitute variables. You can substitute variables and numbers. The variables can be squared. All right. But whatever you are finding the function of, that value is put in the variable. Okay. Now, let's see. Take out these answers. Solve these for me, Vanessa. Take out the answers. Number 4. F of x is 3 minus 2x squared. I want you to find the f of 0, f of 3t.
You said F.
Okay.
F of. Okay.
Okay. Now let me just
It's equal to 3 minus 2x.
okay.
4.
Okay, I want you to solve. Okay, actually it's 3 of them. Really good practice. Okay. First find f of 0, and that one we met the math. Right?
Oh, find F of 0 first.
Yeah, find f of 0 first. So that means wherever you see an x, you want to put a 0. So what would be the answer for A? Maureen, you following?
Yeah, I'm listening. Yeah,
Okay. Vanessa has a test on Monday morning.
I know.
That's why we skip to the functions.
She would get it.
Yeah. So the first one, Vanessa, mathematics, what do you get? Wherever you see an X, put a 0.
Yes. You put a 0.
Be 3 minus 2 times 0.
2 parentheses 0
And
times
0 times 0 is 0.
Mhm.
So what's the answer? What's the answer, Maureen?
Okay. 3.
That's it,
Yeah.
3, because you get that's right. 3
Oh,
minus
3.
0 is 0.
3.
Yeah. So 3 minus 0 is 0. So this would be equal to 3. That's your answer. Okay, 0 times 0 is 0. 2 times 0 is 0. Any number of variable times 0 is 0. Okay. What about f of 2?
F of 2. Okay. 3.
Let's just take
Minus
this
F of
here.
2.
Yep. F of
Same sum, right?
same, yeah, same f of x3 equal 2 minus x squared, which is
So that would be -5.
what would it be?
-5.
2 times 2 is 4. 4 times 2 is 8. 3 minus 8 would be -5. That's correct. Okay, so let me just, Maureen, is that what you got?
No, I didn't even figure it out. I was just listening in.
Oh, you didn't
How
figure
how
it?
you get the 5?
Huh?
How
You
you
know,
get the 5?
tell Vanessa how you got the 5.
Because first we gotta think about PEMDAS, we call it, right? So we think about PEMDAS, so we do parentheses first. So you multiply what is in the, because where the x is, you put the 2.
That's right.
2, and you said 2 times 2 is 4. And then you multiply 2 4s is 8. And you minus 3, right? And you minus 3, remember 3, it's a +3 and a -8. You keep the sign of the larger number. I minus 3 from 8 and you
That's
minus 5.
That's it. You got it, Maureen?
Get it, Maureen?
Yeah.
Yeah, 2 squared, 2 times 2 is 4, 4 times 2 is 8. That's a negative 8 and a +3. subtract, you get a 5. You have more negative than positives. Your answer is negative. Got it, Maureen?
Yeah.
How would you do? How would you do C, Maureen?
Okay, I would put -3.
Let's see. Let's go back and say
Negative, right?
equal. This would be equal to.
-4.
Okay, and let's
Right.
put the 3 minus 2x squared here. And where we see an x, we want to put a -4. So let's just put the -4 here.
Mhm.
Minus.
So Maureen, for the x, you're going to put what? -4.
Mhm.
What's a
Fine.
-4 times a -4?
-16.
What's a -4 times a -4?
Negative,
-16.
Is a what, Maureen?
-16.
Negative times negative gives
Positive.
plus.
positive. So it'd be a plus 16. And
16.
what's -2 times plus 16?
That's 2 2s is 4. Plus 16 is 20.
A -2 times 16
Or 32.
plus or minus.
A plus. Because 16 is higher.
She get 32.
What is it, Vanessa?
Okay, we gotta be a -32.
A -4 times a -4 is a plus 16, Maureen.
Yeah,
A
you get
plus 16 times a -2 is a minus 32.
A -32.
And what's that equal to, Vanessa?
You can equal to -29.
-29. 3 from 12 is 9. That's right. Negative
Right.
29. Yes, that's correct.
Okay.
You
Mhm.
see, Maureen? Plus
Yes.
times minus gives plus. Plus divided by minus gives, plus times minus give minus. Plus divided by minus give minus. In other words, unlikes divide to give you negative, multiply to give you negative. Likes divide to give you positive, multiply likes, you get positive. Okay?
What I do, if this was, let's say, we change the exponent, right, to 3, to cube.
Yeah.
And
yeah.
you get 4 times, and in front here, instead of 2, it was a +2, right? That's how I do it. And because it's 4, you would get, they're all, because even numbers give you positive, odd numbers give you negative.
That's right. Yeah.
That's how I remember.
Well, yeah, if you had to the third power,
Yeah.
you'd have a plus and then times a minus. So you'd get a minus. So if it was say a 2 raised to the -4 to the third power, that would be -4 times -4 is plus 16. Then a plus 16 times a -4 give you a minus 60, what, 64?
64.
Yes, that's correct. Now do the 3t.
3t.
F of 3t. Wherever you see an X, you want to put 3t. So let's just copy this. Substitute for X, 3t. So we put this here. And for the X, we put, for the substitute for the variable, 3t.
You do, all you do 3 minus 2 times 3.
So what would that be equal to?
So therefore, you do the exponents first. So you say 3 times 3, you get a positive 9 because square, but then you multiply 3 3s is 9, right? 3 times 3 is a positive 9 unit. But then you have to multiply 2 times 9 and you get a negative 18.
So 3t squared is 9t squared, right?
9t squared, yes.
Okay, so we have 9 and t square. Let me copy this here.
Yep, 9
t,
9
and let's
square.
put the square there.
Yes. Then when you multiply, you get them back to -3 because you have bring them back to +3, but then you have a -2, so you multiply 9 3s is 18.
So that would give you what, Vanessa? What would that give you?
It would give you 3 -18 t square.
3 minus 18 t square.
Square, right?
Okay. Three minus 18 t square, or if you factor it, it would be this is equal to. So it would be 3 times 1 minus 6 t square if you factor it, right? Because 3 is common to 3 and the 18.
Okay.
All right, do the last one. Okay. That would be 3 minus 2x squared. Let's copy that. And for x, the variable put x plus 2.
Plus 2.
So Maureen, what would you have here for the x? What would I substitute for the x, Maureen?
A 4?
No, x plus 2 is what I substitute for the variable. So this becomes x
205.
plus 2.
All right,
So instead of
2.
x squared, it will be x plus 2 squared.
Yeah, I see.
And what's that equal to, Vanessa?
That's equal to,
Let me just copy this.
it's equal to, I get this. Oh,
2.
equal to negative 2x squared, negative 8x, negative 5. Am I right?
What's x plus 2 times x plus 2?
X
That's plus 2.
There's a mnemonic for multiplying this. What's the mnemonic?
what is it?
There's a mnemonic you use for multiplying, for squaring of an expression. Well, it's x squared, 4x, and 4.
Yeah, but okay. You multiply everything in the parentheses. 2x.
So
2
what's
times
x plus 2 times itself? What's that equal to?
x plus 2 times itself.
It's 2.
Can be 2.
No, it can't be 2. You x
2
plus
2 times x plus. Therefore, you're gonna have a square. X square.
yeah, you're gonna have x squared. Okay.
2, 2.
So let me just copy this here. This is going to be x squared okay, plus 4x okay, plus 4x, and 2 times 2 is 4. plus 4. Okay, and then you multiply 2 times that, and what do you get? Let me just copy this. What do you get, Vanessa, when you multiply that? 2 times x squared would be a minus 2x squared, right? And 2 times 4x, that would be a minus, because it's a minus minus 4x and a minus 4.
Miss Barbara.
A minus 8. Minus 8. Yes.
I'm lost a bit. Yeah, no, I got it, but you got, let me see. We're doing distributive. 2x plus
that minus, well, that minus applies to everything in the parentheses. So minus 2 times x squared is a minus 2x squared. A minus 2 times 4x, this will be minus 8x. It should be an 8.
Yes, that's why.
Right,
That's
and a minus 2 times a plus 4 is a minus 8. Now you just combine what? Your constants, because everything else just appears by itself. So this is equal to, and I'll just copy this and combine the 3 and the minus 8. And what's a plus 3 and a minus 8?
Plus 3 and a minus, plus 3 and a minus 8 is minus 5.
That's right. So that's a minus 5. Minus 2x minus 8x minus 5. That would be your answer. And that's yeah, substituting x plus 2. So x plus 2 has to be squared because x is squared. So the variable is squared. What you substitute in for the variable is squared.
Okay.
Questions?
No, Miss Barbara.
So Vanessa, you're following this okay, right? Let's
Yes,
see
I
what
am.
that's. Oh, that's what it's called, FOIL. That's the mnemonic. First, outer, inner, last. So when you multiply of an expression that has variables in it, like this, is FOIL.
Okay.
First, that's x times x. Outer, 2x. Inner, 2x. And last, 2 times 2. So just remember FOIL.
Yeah.
It's an order to doing this. Okay, let's see. All right, now, Vanessa, do this one.
Which one?
Where it says homework. Evaluate f of 2 minus f of 1.
Okay. Do.
That's a mental math, right? Wherever the x, you for the 2. So what do you get for f of 2?
So you can put the 2 and 1 together.
F of 2 gives you what number, Vanessa? That's mental math.
F of 2?
Wherever you see an x for the 2.
Yeah.
What's f of 2?
12.
You throwing away the 1?
12 and 1, 13.
That's right. What's f of 1?
6. 6 plus 1
Makes what?
1 moment. Let me see.
6 plus 1.
7.
7. All right, Maureen. 13 minus 7.
6 ones.
Maureen, 13 minus 7. 13 minus 7, Maureen.
Oh, 7.30.
13 minus 7.
6.
6. That's your answer.
It's from this.
That's saying mental math, right? F of 2. See, this is 6x plus 1.
Mhm.
And you have f of 2. Let's put the 2 here. So where we have an x, we put a 2. So that's times 2. That's equals 13. And then we have f of 1.
1.
Let's just copy this and put our 1 in. Okay. So f of 1, wherever we see an x, we want to put a 1. So that would be 6 times 1. 6 plus 1, 7. So our answer, we just subtract those. 13 minus 7 equals 6. That's our answer.
Okay.
Any other questions on functions? Let's see if I have another one here.
Hi, this is Rachel from Dealer Services. Your file just came across my desk, and it looks.
Well, that's what we had before. Now, okay, here's one.
Mhm.
Okay. Take the answer out. Solve that one, Vanessa. G of W is 4 over W plus 1. What is G of W plus 3?
What was G of the first?
W. Okay.
So Maureen, what are you going to substitute for W?
4.
No.
No,
G.
W, W plus 3.
W plus 3. See, you're looking for G of W plus 3. So wherever you have a W, you want to put W plus 3. Right?
I see. Mhm.
All right. So that means this W becomes what? W
4 over
plus
to do W
3. Okay.
plus
So
3.
what's the answer, Vanessa?
So
That's going to be equal to what?
4 over 4.
No.
No, 4 over what, Maureen?
4.
Are you throwing away a W?
Throwing away a W, gotta keep your W.
Got to keep the W. You can't throw away anything.
Have to keep the W.
So
W
that would be W what?
plus
What would it be?
3
What would it be, Vanessa?
W over
plus
4.
1.
3
Okay,
plus.
it would be 4. Okay, just add it.
That's
So
it.
it
So
would be W plus 4 over W plus 4.
yeah, 4 over W
What was that we had?
plus 4. Right. That would be your answer.
Oh.
Yeah, 4. And then combine the constants 3 and 1.
Right.
And
Point.
W plus the sum of 3 and 1 is W plus 4. That's your answer. Got it? Let's see if there's any others on here we can do. Okay, now remember functions can be linear, quadratic, or exponential. How do you know from an equation which one's linear, which one's quadratic, which one is exponential? Vanessa, how would you tell from an equation?
Linear have a straight line.
No, I didn't say a graph.
Okay,
From an equation.
from an equation, linear is what has 2, let's say 2x.
Well, linear functions have the form mx plus b, y equal mx plus b, except it's f of x equal mx plus b. All right.
Okay.
What about quadratics? quadratics always have a square.
Carry a square, it has a
F
square.
of x, ax squared plus bx plus c. And exponential functions have powers.
Powers.
All right. Now you can identify equations from a table. You can identify it from an equation or from a graph. Okay.
Yes.
Now, okay. So all of these represent linear. Y equal 5. Now, if you say y is 5, right?
Yes.
What kind of line is that?
Y is 5.
Yes. What kind of a line on a graph would that be?
It would be, okay. Y is 5.
Upper?
It would be an, is it a, okay. Would it be a,
Which line you mean, this blue line
no.
here?
No. If
it would be
y
a
was 5,
X.
how would that look on this? It wouldn't look like this.
No, it would be a, one moment, let me get it out.
It would be a horizontal line. It'd just be a line, because y doesn't change. Because if I had just y and I drew that's why H0y, Hoy, you can remember it. Horizontal, 0 is the slope, and that's on the y, because
Well,
difference
5.
in y over difference in x, if the y values are the same, your numerator is a 0. So when you have a horizontal line, that's to the H, 0 will be your slope, and that's on the Y line.
On the Y line. 0 would be a slope, and
Right.
5 would be.
That's it.
Okay.
So Y is, but if you had X equal to a constant, and that's a vertical line.
Vertical line. So if you have
and your
X,
slope is undefined. That's why you have, you can remember that one by saying, let's just put here.
so your slope is undefined.
VUX. So you can remember these from the mnemonic. Horizontal, and this is a 0 on the Y line. Vertical on the X line, undefined, because now you're trying to divide by 0, because your difference in X is in your denominator, and the X value is the same. So that's why you have U undefined. So just a vertical line like X equal 3. Like if I had here, X is 3. My Y values are changed. That's just a vertical line. That's an undefined slope. U, vertical, undefined, X line.
Okay.
That's the way you can remember it, Vanessa. Hoy, but that's really a 0.
Okay.
0 slope, horizontal line on the Y. Vertical,
0.
vertical line, undefined on the X. In other words, your X is staying the same and your Y value is changing. So your X is staying the same, so you're trying to divide by 0. That's undefined. Divided by 0 is undefined.
Okay, this is undefined, right?
Right. VUX, vertical, X, undefined. Horizontal, 0, that's on the Y. All right. Because you're trying to say difference in Y, and then if the Y value is not changing, the difference is always 0.
Ms. Robert, just give me 2 minutes. Okay.
Okay.
I'll run to the room.
And of course, the exponential, your variable is your exponent, like these examples here.
Ms. Barbara, I'm stepping away from the computer for 2 minutes.
Okay. All right. So Maureen, you know how to recognize linear equations, right?
That's right, sir.
What do they look like? Just give me a simple. Linear equations have what? What kind of lines?
Which one you said?
Linear. Linear equations, what kind of line? I've got one right here. Straight lines.
Straight line.
Straight lines. What about quadratics? What kind of line? Quadratics have what we call parabolas, right? Let's see. Here we
The
go.
upside and down.
Yeah, like a U, or upside down U. And then exponential have they seem to stay steady, then they rapidly increase, or they can rapidly drop. So when they increase, we call it growth, and when they decrease, we call it decay. So that's
This one right here is what?
I'm sorry,
This one right there.
right here, exponential. This is exponential. This is quadratic. Just think of a U for quadratic. They call parabolas, but just think of a U. Okay. And it could be increasing like here, or it could be decreasing when they're upside down, just like exponential functions. Okay, Vanessa, I want you to be able to recognize whether equations or whether functions or linear, quadratic, or exponential. And of course, we've been looking at linear, that's the straight line, right?
Yes.
And what about the quadratic? What kind of line?
U.
Yeah, it's like
Whether
a U,
up or
a
down.
parabola, up or down. That's right. Here we are, right here. There's the quadratic. There's the quadratic, and then the exponential. That's on the
Yes, either up.
the
How do you call
exponential
it?
is, well, it's
Exponential is either, so kind of name like a half, you a half.
yeah. Well, they can rapidly increase and they can rapidly decrease.
Decrease or
And the
growth
two
or
terms we
decay.
use growth when they are increasing,
decay.
and decay when they're
Yes.
okay. All right. Now, now you can also identify from a table whether something is linear or whether it's quadratic or exponential. Now, if you have a table, when you take the differences, they're always the same, and it's always the y values.
Yeah.
If they're the same, then that's linear. If they're not the same, you go to a second difference. And if they're the same, then it's quadratic. Like this table represents linear. This one over on the second one, this represents quadratic, because notice the differences. The first differences are not the same. But then when I take a difference of a difference, I get the same. That's quadratic. Now, if it's a ratio, then that's exponential. So here's one, here's an exponential ratio. 4 over 12, 3, 12 over 36, 3, 36 over 108, 3, 108 over 324 is 3. Now, knowing that, look at this table. Tell me, oh, well, I put the answer there. I told you linear. Okay, the reason you know it's linear because what? 14 minus 10 is what?
4.
And 10 minus 6?
4.
6 minus 2?
4.
2 minus a minus 2?
4.
4. That's like a 2 plus 2. Minus 2 minus a minus 6 is a minus 2 plus 6 is 4. And then a minus 6 minus a minus 10 is minus 6 plus 10 is 4. All right. This one is exponential. You can start at the bottom. You don't always have to start at the top. 32 over 16 is 2. 16 over 8 is 2. 4 over 2 is 2. 2 over 1 is 2, and 1 over 1/2 is 1 times 2 over 1, which is 2. That's a ratio. That's exponential. Right? So you can determine from an equation, and then once you see a power that's greater than 2, you know it can't be quadratic. The highest power a quadratic can have is 2. Okay, and then the linear equations do not have a power greater than 1. Okay, and exponential equations must have a power in one of the variables. All right.
Yes.
Now let's just, I think I have some you can try. Let's see. Let's see.
Great.
Oh, I think I gave you answers on all of these. I have, these are the ones that have answers. Now, sometime, this is something I want to show you. Sometime when you're trying to find a function, you're not looking for the variable, you're looking for the actual, what we call the Y value, like this one.
Mhm.
Instead of solving for the, well, okay. Let's see if this one, I want to give you one. Sometimes you're given the value of the function, you define the value of X, like this one.
Mhm.
Let me just take this out. Okay. Now, I gave you f of X and I say find, if f of X is 15, find X. How would you solve that, Vanessa, with this equation?
What the value of 50?
Okay, this is the function.
Uh-huh.
But I gave you the value of the function. In other words, that's like our Y value or our dependent. Okay, whatever's here is dependent upon the variable here. But I gave you this and I want you to find X, right? So if f of X is 15, that means you're going to put the 15 here, right?
Mhm.
And solve for the X. So what's the X equal to? Maureen, you know?
The X equals, I don't know, to 6.
No,
No.
one moment, let me see.
What number do you subtract 3 from and get 15?
What number?
Uh-huh. No.
18.
18. So that means 2x is 18. So what's X, Vanessa?
9.
That's it. Mental math, you got it. Yeah. See, the function 15 is given for your f of X. You define the X that gives you this 15. So when you get here, you just do your mental math. You says, I have 15, I will subtract 3. What do I subtract 3 from to get 15? And that's only 18, right? 18 minus 3 equal 15. This is how you can just logically do your answers. So that means 2x equal 18, and only one number multiply by 2 to give 18. That's 9, right? So x equal 9. 9 times 2 is 18. 18 minus 3, 15.
Wait, let me see. Let me write this.
Okay, so sometimes you're given, remember, this is what we've been calling our Y value. That's our dependent variable. The one here is dependent. In other words, what's over on the right gives us our value on the left. So the X value, our input, gives us the 15, our output. So sometimes well, most of the times we may be looking for the input, but you sometimes given the output, I mean, most times you're looking for the function value itself, given the input, right? But sometimes you're given the value of the function and you to find what is the variable.
Find X.
Any questions?
Let me see one moment.
And sometime in some word problems, you're given the setups and you determine which setup is correct. Now, I have a word problem here. Any questions?
One moment, Ms. Barber, just
yeah. Any questions on number 2?
No, not so far.
See, we've been calculating
True.
variable. We've been
Okay.
calculating actually the value of the function. All right, given the variable. But now we're giving you the value of the function and we want you to find the value of the variable. So it's like I'm giving you the y value and you find the x. Although it doesn't have to be those variables. I mean, it doesn't have to be x and y, it could be something else. But generally we think in terms of y as our dependent variable, x our independent variable, okay? Y is dependent on x. Okay.
Yes.
Questions? Vanessa, is it clear?
Yes, that's clear.
Now, I want you to write the function for this word problem. All right. Now, I'm giving you a word problem and I want you to write the function for it. Mary saves $100 weekly for her birthday party. If she already has $1,000, how much will she have after 22 weeks? Now, I don't want you really to solve it. I want you to write the function that shows this relationship.
Okay, so Mary saves $100 for her birthday party weekly. If she
Yes.
already has 1,000, so for 1,000, she already saved equal.
We know this is a linear function, right?
100 equal.
There is a 100 per week.
If how much weeks if she save 22 weeks? You just wanted to write out. You don't need
Yeah, I
to
want you to
correct.
write the function that shows this relation.
You don't want. Right. First step, write the function that shows. So therefore it said, okay, this is a linear, right?
This is linear. Yes.
So therefore, let me ask you. It write 1,000 equal to 100 W plus 22?
No, you're going to write it as a function. In other words, write it as a function.
You mean like FX like?
Yeah, that's a function.
Oh,
Write it as a f of x equals something.
Oh, yeah.
well, F of
F
X
of
equals
X
1,000.
1,000. F of X cannot equal 1.
So your
The
x,
1,000 is the Y
what
value.
is your x? What would be your x here?
That would be 1,000.
Nope,
No,
it's gonna be 100.
no.
No, it's gonna be 22.
By elimination, right?
It's
Okay,
gonna be
so
22.
this would be 22.
22.
And what's that equal to?
22 equal to
100.
1,000. No, you can be equal. Maureen just said it. 100.
100 what?
100.
Dollars.
No,
Well, it's
100
$100
weekly.
a week.
That's the rate of change is the slope, right? So
Yes.
that's like our M. So a M is a 100 times X number of weeks plus she's already saved 1,000.
1,000.
All right. So f of 22 for our x, we'd have 100, and we know what that's our 22 plus.
Let me get this whole thing. I don't write that.
1,000. So after 22 weeks, how much would she have? $3,200.
And 200. Let me write out the same thing. Don't remove it, Miss Barbara.
Okay. So you write the function, and you rewrite it in terms of x being the number of weeks, right? So f of x, where x is the number of weeks. Let me put here x equal number of weeks. All right. So the function would be f of x is 100 saved per week plus 1,000. That's like equivalent to what? Our constant, because that's how much she has, or a y-intercept if we're talking y. And notice this looks just like y equal mx, where m is the slope plus b. But instead of y, we are saying f of x. So this is dependent upon the value of x, the number of weeks. But they gave us, she's 22, she's saving for 22 weeks at 100 per week. So that's f of 22, 100 times 22 plus what she has already. Any questions?
CE, one moment.
All right. So you want to be able to, and normally a question like this, they would probably give you multiple choice of functions, relations, and you pick out the one that's correct. And this one is really a linear, and just think y equal mx plus b. If you keep that slope intercept formula at your forefront, it'll just help you with the linear equations. All right. And just remember the quadratic, you have a square and you have a general format, ax squared plus bx plus c. That's the general format of the quadratic. All right. And if you're given a quadratic equation, you can just, or you given the quadratic formula and they ask you which is correct, then you know you have the a and the b and the c. A being the coefficient of the x squared, b the coefficient of the x, and then c being the constant. All right.
Okay. Thank you so much. Yeah.
Any questions? Is it clearer now, Vanessa? The function?
Yes.
And function is just another way of writing what we've been working with our equations, except we don't say y, we say f of x. That's why sometimes functions are taught with algebra, because it's really algebra.
Yes, and it's algebra.
All right.
Yes.
Now I will send you Vanessa, you need the function here we went over. You want me to send you this when I email?
Because I write them down. I have them.
Okay. All right. So now I have, let me see. Let me do a new share.
When I write down, I remember things better than.
Yeah, you're right. Absolutely.
Yes.
Let's see. I have a. Let's see. No, that's not it. I think I've gotten rid of math topic, solving linear equations. No, I think I got rid of it. Let's see. No, I don't see it here. Okay, so I have, well, anyway, I'll email it to you. I have a worksheet for you to do. It's 5 problems. Like I say, multiple choice, like a review of algebra, some things you've gone over, Well, actually, all of the things we've gone over. And I need you to just text me the answers in multiple choice. So you say 1B, 2C, etc., etc. Okay. So
Mhm.
I will be sending you that because, as I said, we don't have class next Thursday because of Veterans Day. That's a holiday on the 1199 calendar. All right.
Mhm.
So I will send you work for you to do, to send to me in the interim. In other words, I'll send it along with what we went over today, and I need you to send me the answers. Let's see. Next week we don't have a class. Well, you could just send them before. Let's see. What is the? Let me look at my calendar. So next week we don't have class.
You don't have class Thursday. You got Monday?
Yeah, we have class on Monday.
Yeah, okay.
We don't have class on.
Thursday. So Miss Barbara, last we hear from Mercy.
I haven't heard from Mercedes in a while.
Who you call she I can't remember she didn't know.
Who?
The Haitian lady, who she didn't know?
Who?
The Haitian lady, I can't remember her name. Annette, Janet.
Yannick? I haven't heard from Yannick either.
Uh,
I've got to call her.
mm,
Okay, so now 11th, no class.
uh-huh.
We will have class on the 8th.
Mhm.
Okay, so actually I need you to send me those answers before the 15th. Okay,
Okay.
before a week from Monday. If you get
Uh-huh.
them done before, it's okay.
Which
You
one
can
is it?
text me the answers. I'll text you back the results.
Mhm.
All right. Any questions on anything we've gone over?
Not right now, because I ready to talk a lot.
Okay. All right. So the work we went over before the functions, I'll be sending to you.
Mhm.
All right. I'll email that to you. And of course, we recorded it. So
Yeah.
this session will be on YouTube for those who missed.